Good afternoon, everybody, and welcome to the MIT Alumni Career Lunch and Learn webinar series. My name is Ellen Stahl, and I head up the Alumni Career Programs at the Alumni Association, and will serve as host and moderator for today's workshop. Our webinar is being broadcast live, and we'll be collecting questions from you throughout the presentation. Please type your questions in the chat box in the lower right side of the WebEx window. This webinar is being recorded and available to view online 1 week from today on our YouTube channel, which you can access from the alumni website. A few technical notes before we get started. We have hundreds of people on our online audience today, and due to the large size, the audience is all muted, which means you can only ask questions via the chat box on the right side of your screen. Thank you all so much for taking time out of your day to join us. Our presentation is Getting Started in Data Science the MIT Way. This webinar is scheduled from 12 o'clock to 1 o'clock. We will hear from our presenter until about 12:30, at which time we will open our Q&A portion of the program. Again, please type your questions in the chat box at any time during the webinar. You don't need to wait until the Q&A segment to start asking your questions. Before we get started, it is my pleasure to introduce you to our presenter today. We are extremely fortunate to have with us Sebastian Gutierrez, class of 2003, course 18, who is the co-founder, co-editor of Data Science Weekly, a weekly newsletter subscribed to by tens of thousands of data scientists who read to learn about the latest and greatest development in data science. After hearing from readers about the challenges of breaking into the field, they have helped thousands of people in starting and changing their careers into data science. Sebastian is author of Data Scientist at Work, an interview series with 16 prominent data scientists. He also founded Dashing's D3JS.com, where he provides online and offline corporate training in data visualization, and D3.js to a diverse client base ranging from Fortune 500 companies to startups. Thank you sincerely for being here with us today, Sebastian. I hand it over to you.
Thank you very much, Ellen. It is a pleasure to be here in sunny cyberspace today with all of you, and we will get started. So as Ellen very kindly mentioned, we are here today to get started with Data Science the MIT Way. So this is an alumni-only presentation, so all of you are insanely intelligent and good-looking. So here's what we're going to talk about today. We're going to go through our goals, what are data scientists, what does a data scientist job entail, and once we figure that out, we're really going to talk about what does it mean that you want to be a data scientist. Obviously, you have heard that there's this new thing called data science. It's supposed to be the sexiest vocation out there, but what does it really mean and how can you actually get into it? So we're going to start out with the goals. So in the future, you are going to become a data scientist. You have probably already started to learn data science or in the process of it. What we're going to go through in the next approximately 25-30 minutes before we get into the Q&A is how do we get from A to B? And this is actually the most important thing, and one thing that a lot of people miss out there is that when you start out with data science, it's very unclear what exactly you're supposed to learn. Are you supposed to learn deep learning, maybe cutting-edge technologies? You probably have heard of Hadoop, big data, giant data, web-scale data, grande data. What is it that we're going to do? So we're going to spend the first part of the presentation really figuring out where it is that we need to go. So what is a data scientist and what are they? This is the quote that was launched Data Science, Hal Varian. For those of you who are in economics, you may have gone through his microeconomics book. He works at Google. The really key part of this is that it's the ability to take data, understand it, process it, extract value from it, visualize it, and communicate it. So those are all key portions of what will define data science for us. You have probably heard the snarky definitions of a data scientist as a statistician who lives in Silicon Valley or San Francisco, someone who uses a Mac, or someone who has changed their job title. But that doesn't really tell us about where we need to go or what we're going to do. Some more helpful definitions are using data that's too big to fit into a single computer, or someone who knows statistics better than a software engineer, or someone who is a better software engineer than a statistician. That gets us part of the way, but it doesn't really tell us all that much on how we actually go from where we are today to getting a data science job and being a data scientist. Drew Conway in 2013 comes out with a Venn diagram. He says, well, you take these hacking skills / coding, you mix it with your math and statistics knowledge, and you mix it with some type of expertise about the business. And the intersection of those three is really what data science is going to be about. If you remember the Hal Varian quote, however, Hal Varian talks about how you then need to communicate it. So someone came up with a even better data science Venn diagram that has a communication aspect to it. So you take Drew Conway's data scientist, you sprinkle in some communication, and now you are the perfect data scientist. I am going to step back a second and say the really true definition of what a data scientist is a person whose job title is a data scientist. This gets us away from tooling, from all the different things. If someone has hired you as a data scientist and your job title is a data scientist, then you are a data scientist. A little bit tautological, but we'll go through why this is. So now that we know that we are going to be a data scientist when we are hired as a data scientist, what does a data scientist job entail? Diving deeper into Venn diagrams and confusing charts, the next one talks about, well, what is the process? What types of things do we actually do? So we talked about communication, presentation, problem solving. We analyze different parts of the business, and we have some type of business strategy that we're going to go through. Okay, so what exactly does that mean? In much plainer language, it talks about understanding the customer, defining metrics, using statistics, math, some type of computer language, some type of data, and asking good questions and making it actionable. Okay, a little bit better, but it's still not quite there. And the reason why this is that data science is a very broad term. If you go out and you talk to someone and they say, I am a chef, okay, so you know that they are cooking something, they have food, but it doesn't tell you that they're a pastry chef or that they are a pastry chef who specializes in French cuisine. The same way, data science can be broken down into whether it's a product of the company or whether it's a function. So in the sense of a product, there are companies like Clarify.ai, which is a product. What they build is they build image recognition software. So you send them an image and they send back to you tags of all the things that are present in that image. On the complete other side, you have data science as a support function of a company. Using a simple example like Amazon, the recommendation products, people who have viewed this have also viewed this, or you bought this, you might also like this. This is a support function of the broader goal of Amazon to be the everything store. You can also break down a data science job in research versus implementation. A lot of different companies are starting to build AI labs or data science labs where they are doing actual research. So people are moving from academia and going into these research labs, and they are publishing papers. On the complete other side of the spectrum, there are people who do the actual extracting of the data, modeling of the data, and building internal tools or external tools for companies where they are doing the implementation of the data science and the implementation of the new algorithms that are coming out of the research labs. Another way that you can break it down is full stack versus specialized. So in some companies where they are very small, or in many startups, they hire a data person or a data scientist, and they have to come in and they have to do all the tooling. they have to do the data engineering, that is building the pipelines from getting the analytics or getting the data from the database into where they're building the models and then back out to some type of useful product. And much bigger companies or companies that have very large data science teams, when you come in or when you work with them, you focus on a very specialized part of the process. And so in this case, it's going to depend on the age of the company, the group, the size of the group. And so the data science role can be very different depending on where you are. Similarly, along these lines, data science role can be you focus on one thing or you focus on all things. So I talked about how if you come into a startup or a smaller company, if you're one of the first data people who are hired, you're building out the infrastructure, you're building out the modeling. And then it depends on whether you are going to focus on one type of solution. Perhaps you're doing predictive analytics, or you are doing recommendation engines, or you are doing everything. Marketing decides that they want to do some type of new product for their customers and they need a segmentation tool. HR decides they need some type of attrition model to figure out how many candidates they need to hire, and for the employees who are already working, how long they're going to stay and when they're going to leave. So depending on the depth of the team and the size of the company, you might be focusing on one specific thing, or you might be focusing on many specific things. And not only that, you are now a data scientist, and now you have to use all these tools under the sun, some of which you may have heard of, some of which you may not have heard of. This list of tools comes from Indeed.com, which is a job website. We looked at the first 50 data science job postings, and for each time a tool showed up in a job posting, we gave it a check. So at the very top, you see R, which is a statistical programming language. Then you see SQL, which is a structured query language. It is a way to talk to databases. Then you see Python, and you see Hadoop, and you see a whole bunch of other things. You may even be surprised to see Excel in there. This is one of those things that, depending on what type of role you have, what exactly is the output and what you're doing, you're going to have to use many different tools, which, as you may have already encountered as you've been learning data science or looking to switch into a data science career, every single job posting is going to list as many tools as possible because they want to try to get someone who can help them. So what do we do with this knowledge? We have the Venn diagrams, we had the Halvarian explanation, and we know that we need to use these tools. But how do you, given that you have a unique education, work experience, industry knowledge, statistical knowledge, mathematical knowledge, programming knowledge, seniority level, and where you want to live, how do you figure out what kind of data scientist you want to be, and what is it that you are going to need to do to close the skill gaps from where you currently are to where you are going to go? Obviously, because you are unique, you're going to have to learn very unique things. And not only that, you're going to go out and you're going to look at these job websites. This is, again, Indeed. And if you look for data scientist without quotes, so data or scientist or data scientist can appear, there's about 21,000 jobs when I took the screenshot. Or if you put it in quotes, so it's looking for the phrase data space scientist, there's 3,200 just about data scientist jobs. So given what you need to learn and all these various tools, how do you figure out what is the right job for you and how you're going to get it? The way we're going to do it, and the way I highly suggest you do it, is through revealed preferences. It's what you do when figuring out what you want is very hard. On the screen, you will see a Sony Walkman. For those of you fortunate enough to have lived through the 80s and the early part of the 90s, you put a cassette player, it is a cassette player, you put a cassette and you can listen to music. Sony was doing market research to try to figure out how they should expand the brand. Up until that point, they had been doing black-only cassette players. And so they brought in a research team, they brought in a bunch of hip young people and they said, what colors would you like? The color that won was yellow. And normally this is where the study would end, but this marketing team was very smart. And so what they did is they said, okay, great, thanks for coming in, thanks for all the help. Now that you are leading, there's 2 tables, please take a free Sony Walkman with you. On one table was black, on one table was yellow. As you can probably guess from where the story is going, all the black ones were the ones that were taken, no one took the yellow ones. So for as much as people said, ooh, yes, yellow is definitely the next color, as it came out, no one actually wanted it. So we need to figure out, given where you are and who you are, what are your preferences for the education that you have, what type of work experience appeals to you, what kind of industry knowledge appeals to you, all the way down. And this is because at the end of the day, you don't need 21,000 jobs, you need one job. And you want one job, and there's going to be one job that excites you the most out of any of them. And so when you want to become a data scientist, when you start studying or you continue studying to be a data scientist, you don't want to study to get all of the 21,000 jobs. What you want to do is you want to study to get this one particular job. And so the way we do that is through the pairwise comparison process. And what this process basically is it's going to elicit your revealed preferences of what type of jobs you would like. This process is a little bit long. I'll let you read it later and you can look at it as slides. But what it basically boils down to is you're going to go to many different job posting sites. You're going to look at a list of data science jobs and you're going to compare 2 jobs at the same time. Not all the jobs, just 2. And you're going to holistically think about, do I prefer job A or job B? And whichever one wins, you're going to put into a list. You do that for as many results as you want. We usually suggest 10 pages of results. And this is because we really want to tease out of the data what it is that you prefer. Once you have that first round of winners, you'll do it again between all the winners. And then once you have done that, you'll do the process one last time. So at the very end, you have these jobs that you have preferred over other jobs that you have done through the 3 rounds. And so here is a simple example that I took from, again, Indeed. The first one is a job in Stamford, Connecticut, where you will be standing in front of clients and constructing and delivering analytics solutions. The bottom one is data scientist in medical AI. Oscar Technology is a company in San Mateo, California. There you're working with neural networks, supervised learning. So right off the bat, just even looking at these 2 jobs, you have a chance to compare, well, one of them is $150K a year, one of them is $100K. So maybe through the 3 rounds, you discover that you really just are looking for more money, and that's great. Everyone loves money. Or maybe what turns out is that you really just want to be located somewhere in Connecticut, or you really want to be in California. Or digging a little bit deeper into the description, what comes out of the data is that you really like positions that put you in front of clients or where you're dealing with outside people rather than joining in a team that already exists where you're just building on the algorithms. So again, you do the 3 rounds, and as you're going through this, you will then have to analyze the data. And so this is a slightly backward way to look at the job hunting process. Most people say, okay, figure out what it is that you want, and then go and look for jobs. This way, what you're doing is you're looking at what hiring managers want, and then teasing out what your choices imply, and then where those gaps are. Because all a job is someone saying, I have this problem that needs to be solved. I need someone to come in and help me solve it. So as much as you are unique and as much as you are wonderful, there's someone who needs a problem to be solved, and the only way you will be hired to solve it is if you can, in fact, solve that problem. So you have to figure out, based on the data that you've teased out from all of these comparisons, what is it that they really want? Is it a hard requirement? Do you absolutely need a PhD, or is it a soft requirement in that, well, PhDs are preferred, but if you've done project work or if you have done work related to this particular problem that we are solving, we're okay with it. Again, is it a generalist position? You can also look on LinkedIn or on Twitter, see who else is already on the team, what else they're hiring for. If it's a startup or if it's an existing company that's been around for hundreds of years or 100 years, then it's very different, and you can figure out what it is that they want. If you're plugging into an existing team, it's going to be very different than you're coming in and you're going to be building the data stack from the bottom to the top. Once you have this, this is where you start to build the action plan to actually become a data scientist. You will have a set of criteria of what you know, what you need to know, and you just have to figure out a way to get from where you are to where it is. And this is why I call it the MIT way. A few things that I learned about MIT was that if you care, you can go so much further than if you don't care. MIT teaches you to over-prepare for all aspects of life. That hard work really does work, outwork the competition, and the most important thing is ask for what you want. So you have now found all these jobs that appeal to you over all these other jobs, and these are the jobs that you want. Now it's much easier because you know where you're going. You have your, as they say, your true north. Anything that you do from now on, if you want to become a data scientist, want to be hired as a data scientist, will be based on getting to this particular job. The way to do that is work backwards. So we now know what a data science job requires. We know who you are. You just need to fill in the gaps. And the way to do this is by doing projects to fill in the gaps. And the reason we do these projects is because you really need to de-risk the hiring process for hiring managers. As you can imagine, hiring managers, all that they see of you is a resume and maybe a cover letter, and maybe if you send in a portfolio of projects. Very few people put portfolio of projects, and what it allows you to do is show that you can do the job. Again, hiring managers are hiring someone to solve the problem. If you can show that you have already been solving this type of problem, it makes it a very easy decision for someone to hire you. As you can imagine, doing data science projects means that you are slowly getting immersed in the tools, you're slowly getting immersed in the mathematics and the statistics of what you are doing. You are getting immersed in the specific lingo for the specific industries in which you are working. Doing a portfolio of projects also is one of these things where it's quantity versus quality. The more you do this work, the easier it will be. It'll be more facile for you, and it'll always be on the tip of your fingertips. Again, show, don't tell. It's much easier to tell someone, look, I can come in and help you solve your problem if you point to an existing body of work that shows, yes, you have in fact solved parts of the problem. You may not have solved all the problem, but you have solved enough of it that someone is going to be comfortable with you coming in and solving the rest of it. An interesting thing about data science is that unless you're doing a research position where you would be in academia anyway, is that a lot of the work that you're doing is going to be replication. So there are standard procedures for creating a recommendation product. It's not like you have to figure out from ground zero how to actually build one. What you can do is you can go out and find tutorials that people have constructed these types of projects. And because you know exactly the types of statistical programming languages you need, you know the data that is wanted by these types of job adverts, you can just go to Google or Bing or your favorite search engine and say, introductory tutorial for Python recommendation engine, or introductory tutorial for building a survival model in R. And what you can do is then you can go through these blog posts and these tutorials, and by doing this, you're replicating someone's work, and you can focus on learning what you don't know, rather than not only constructing the scaffolding of what you don't know, but also doing it at the same time. Which brings us to the data science process. Rather than doing giant projects, it's much easier to focus in on the specific parts of the data science process. as you have been learning and perhaps even been asking different people, how do I get started in data science? You may have heard of a company called Kaggle, which does data science competitions. They are fantastic, but the thing that they are missing is that they don't actually see the whole data science process. What they see is they see a cleaned up data set that is given to you, and what's graded and what people are lauded for is doing the modeling rather than the much more important and much more time-consuming getting the data, organizing the data, transforming the data, communicating the data. So when you're doing these data science projects for your data science portfolio, rather than doing a large one, you can just pick off different parts of this process to build your project. So when someone is either looking at your resume, looking at your cover letter, or speaking to you in an interview, you can say, oh, I see that you have been using SQL to load Twitter data to predict this. Well, I have done projects where I get data from Twitter, and that is one thing I have done. I noticed that you are using MongoDB, which is a type of database. Guess what? I have done a small project where I store data from Twitter and onto MongoDB. Or they tell you that they're using a specific Python library like NumPy, or they're using some type of tooling from the R statistical programming language universe called the Hadley universe. Hadley is a prolific open source contributor in the R space, and he's got many wonderful tools for tidying data and cleaning data. So if that's mentioned in the job posting and it is something that you have done, you can do a small project, and through doing all these small projects, you will build your knowledge and you will be very, very ready to build the greatest resume in the world. And this is because by doing all this work and by thinking through this, your job resume for a particular job will be as close as possible to 100% match to the job advert. And really what you're trying to do is you need to be so good that they can't ignore you. There are hundreds of people, thousands of people who are enrolling in boot camps, data science, massive online massive online learning opportunities. Everyone is going to come out with the same thing, but what you're going to have is you are going to have a resume, a data science portfolio, and the ability to speak to exactly what it is that this person is looking to solve, which is what they want. And because you have gone through all this work, it's going to be much, much simpler and easier when you start looking for that specific job, because you've already filtered based on your preferences, so you'll have an idea of what type of keywords and what type of jobs and what type of companies and where you can look. So rather than going on Indeed and typing data scientist and looking at works, you can say data scientist, comma, Python, comma, predictive analytics, comma, Twitter, or whatever your preferences are, and you can look in California or Connecticut or New Jersey or London or Shanghai or anywhere in the world. The other thing to remember, and this is going back to asking for what you want, is that many times a lot of these data science jobs, because it is a new industry, they're not published. They're not publicized. So what you'll see is you'll see someone who is a data scientist publicize on their blog or on Twitter that they are looking for someone, and that is how the position will be filled in. And unless you have done this work where you have figured out what it is that you want, you won't be following the different types of people who already have the types of careers and already have the type of experiences that you want. The other thing that I didn't know until much later, which you should definitely do, is informational interviews, because you now know what it is that you need to get the data science job. You can start reaching out to people who already have that job, and you can talk to them about the projects that you're already doing and say, look, I'm doing this type of work with this type of data. I saw that you're doing this. Do you mind if we have a quick chat? This type of weak networking, that is, you're not trying to become your friend, you're not asking them for a job, you're just saying, hey, you're doing this cool thing with this tooling and data that I'm doing. This is the way that researchers have showed most people get their work. So I assume that Ellen has got hundreds of your amazing questions.
Yes.
And they will be based all on basically what type of business background, what type of technical background, all of these things. And so in conclusion, before we start, I really like to be action-oriented, so I'm going to take the next 60 seconds before we start and ask you to write down when you're going to spend 5 minutes putting what you've learned and what your thoughts down on paper and what you're going to do. And then we'll continue. All right, 10 more seconds, so finish scribbling it out. And as you're doing that, if you're interested in learning more from myself and my partner, Hannah Brooks, we have data science articles on our website, and we also sell data science guides, basically everything that we have covered in much greater detail. Basically, we have answered hundreds of emails related to these questions, and we put it all in one small guide to do. Also, after this, sometime in the next couple hours or the next couple days, you're going to receive an MIT alumni survey. We want to hear from you. Seriously, what did you like? What did you not like? What other topics do you want to learn? What deep dives or more depth do you want? If you tell us what it is that you want, we can give it to you, whether you want something specific to data science or something specific to job searching, or if you want another topic in a related field, tell us and I can help, or definitely Ellen will help with that. And lastly but not least, it has been an honor and will be an honor as we get into questions. Please don't forget that you're amazing. We live in this amazing, amazing time with amazing people like you who actually care. And there's not too many people, for as many people as there are in the world, who are really putting together effort to learn things and to do new things. You'll find that if you ask people, what have you done in the last 90 days to move forward, to reach your dreams, very few people have a concrete answer. All of you on the call today have done something like that, and I am very honored and proud of all of you. And so thank you very much. We're going to do Q&A now. Ellen has the questions and she'll read them out and I will answer them. If you have any other questions that I either didn't get to or that are somewhat personal in nature, please email me. Realize that I'm probably going to get a lot of emails today, so I will respond in the next couple of days. And then in the appendix, there's a bunch of resources for the websites, podcasts, communities, and blogger lists. So I will take questions from Ellen now.
Great. Sebastian, thank you so much. And yes, we have so many questions, and I apologize in advance that we will not get to everybody's questions. So please take Sebastian up on his offer to reach out to him, and please be patient with his response time and recognize also that it is the holidays, so he might also be taking some downtime as well. So thank you so much. But I guess my first question that seems to be everybody's burning question is, luckily and fortunately, a lot of the audience has a day job, and many people are interested in transitioning into this field, and there are lots of boot camps out there. So this is sort of a several-part question, and I'm just going to sort of rapid fire a bunch of them out there, and you'll get the gist of what I'm really asking here. So boot camps, certificate classes, do you really need them? Do you really need that certificate? Does an employer want to see that? Or are you really just taking these sorts of classes or courses because it connects you to the right people that you really need to know to get those jobs? Do you really need these things? And if you do need them, what's a fair price, since some of them seem to range from a couple $100s to thousands and thousands of dollars? Can you talk us through navigating some of those to understand what the value is or isn't?
That's a great question. So boot camps, fellowships, what are they? Do we need them, and are they worth it? So the dirty secret of the boot camp industry is that they make money off of getting you hired. So while they like to say that they have a very low acceptance rate, the reason why this is that hand wavily, if you get accepted into a boot camp, you didn't need the boot camp, because they are going to, within 8 to 10 weeks, turn around and try to quote unquote sell you to employers, which is how they make their money. So what a boot camp does is it brings you in, and generally what they do is they have a week or two or a couple days where they teach you some of the tools, they teach you the lingos, they have you do 1 to 3 projects, and then they have you do a lot of interview training and then put you in front of employers who will like to hire you. Depending on your learning style, this is useful or not useful. If you need some space where you need to block out some time and say, hey, look, I need to do this regardless of what happens, boot camps can be very useful. On the other hand, if you are very good at self-directed learning, which, as these are all of your MIT alumni, I assume all of you are amazing at self-directed learning, you don't really need them, because for the most part, you can learn what it is that you need to learn. Fair price, it really depends on what it is that you are willing to pay. Some of them are free. Some of them, like you said, are tens of thousands of dollars. It's really up to you. But the thing to keep in mind is that they're going to teach you a general amount of skills. So they might go through a bunch of different machine learning libraries. They might teach you Python. They might teach you R. They might teach you a couple different database technologies. They'll have you put together a project and something that mildly interests you, and you might work with other people. But it's never going to be this backwards approach that we covered, where you do exactly 100% what you need to do and you ignore everything else.
Great. So how many programming languages do you really need to know to be a data scientist, or to consider sort of transitioning into that field? And if you do need to know a number of languages, what would you say the top 1 or 2 absolutely have to be?
So you do need to know programming. So if we look at the halfway snarky definition of you're a statistician, or you know more statistics than a computer programmer, or more programming than a statistician, you need to program. At the end of the day, there are very few jobs where you are just thinking and you're telling someone to do the programming. The top 2 languages are Python and R. It will vary. Both of them can be easily picked up probably within a week, so you somewhat know. What will be the interesting thing for you is, depending on what type of job and what type of thing you're doing, what are the libraries that sit on top of those programming languages? If we go back to one of the earlier slides, oops. You see that on these 50 job postings, R showed up 30 times, Python showed up 22 times, SQL showed up 27. I would say learn SQL and either R or Python.
Okay, great.
And you can just Google introduction to that and it will show up.
Great. Can you remind us what the sort of core competencies and skills are required for a data science position, and maybe what the typical, quote unquote, typical background is for a data scientist?
So the core things are basically math, statistics, programming, and business knowledge. What you find is, depending on what type of job you're doing, you might have to use one of these languages.
Mm-hmm.
So there is no background necessary. Some of the more famous ones, some of the more famous data scientists came out of psychology PhDs, psychology masters. This is because setting up experiments is a big part of looking at data science. There's also a large range of people who came out of math and statistics backgrounds, as you can imagine, also computer science. So there really isn't a cut and dry. The more pertinent thing is that people are curious and that they are willing to learn tools at a very, very rapid pace. And this is because data science tends to be very open. Most of the people who work at research labs, they are all publishing all the work that they are doing. And so you need to be constantly learning as the field grows and as the field becomes kind of more divided into, okay, you're doing data science and finance, or you're doing data science at a non-for-profit, or you're doing data science at a retailer, or you're doing data science at a brick and mortar store. You need to learn those tools as well and how that works.
Great. Where can you direct people to see good examples of solid data science portfolios and what that looks like?
So data science portfolios, most of the bloggers that you will find on here will have some type of data science portfolio that they have constructed.
Okay.
For the most part, it's hard to find someone who has a good data scientist portfolio geared towards getting hired, because most of the people on this list will have already been hired, so they just have a blog of these are the different things that they are doing. What I would say is if you put together a data science portfolio, it should basically look something like this, where you have your name at the top, you have contact information, and then for each specific part of the data science process, you list a couple of projects that you have done. Because from that, someone can look at it and in 30 seconds, 2 minutes know, oh, okay, these are the tools they've worked with, these are the data sources they've done, and this is how they've interacted with that.
Do you feel that data science is something that can help people move into product management? Do you see those things connecting?
Yes.
Can you talk a little bit about that?
Yeah, not very helpful to say yes, is it? Yes. Well, I'm going to stop saying yes now. Product management is this idea, at least in my mind, of you have some product that you are helping other people internally or externally through some type of software, some type of process that you have built. By being a data scientist or a data analyst or a data engineer, you are the one who is closest to the data. You are the one who is closest to the beating heart of the company, of the non-for-profit organization, of the organization. So by being closest to the data, you will get a lot more insight than most other people will, because you know exactly what is going on. And so moving into product management or becoming a product manager of a data science function or of data science products, you will have already had exposure to what is actually really going on, and that's a very important thing.
Can you talk a little bit about machine learning techniques and how that's related to data science, or is it a subset of data science?
Yes, so machine learning, for the most part, looking at this slide 39, falls into the part of the modeling aspect. So the data science process, you get some data from somewhere, you store it into a database, you then extract this data, you organize it in some type of usable subset, you clean it up. So what that means is, okay, maybe the dates are off, maybe you have some data that is missing, you figure out how to impute it or you strike those things. You figure out how to transform it into a way that your statistical programming language will use, and then you use machine learning. So the machine learning aspect will be what the Kaggle website and Kaggle competitions really focus on, is, okay, feature engineering. So what variables should I use? So let's say you're the New York Times and you're trying to figure out, how do I get someone to subscribe to my website? Well, you have all these logs of people coming in who are subscribers, people coming in who are not subscribers. How do I use the data that tells me to figure out what model should I use? Should it be explicable? Should it not be explicable? How do I actually put it into production? And that's where the machine learning aspects will be. And so that machine learning is a part of data science, but it is not all of data science.
Thanks. In thinking, I guess, sort of more big picture and the types of problems that people are trying to solve, can you talk a little bit, maybe in some detail, what are the kinds of problems that nonprofits or maybe governments are looking to address with data science versus what the corporate or the business world might be looking to address?
Sure thing.
That you see. Mm-hmm.
Yes. So, big picture, non-for-profits, at least ignoring the government for now, a big part of what they do is figuring out how to get donors to give them money. So you can imagine that given a data set of people who have interacted with the nonprofit before and who have actually given us money before, you can build predictive models on if we throw this type of event and we get these people in, what do we need to do or what do we need to show, or how can we get more people coming in? And so that's kind of the dirty part of being a non-for-profit. You need money to exist. Specifically with a non-for-profit, there's all types of work that's being done by groups in the University of Chicago, Hewlett-Packard. There's an organization called Data Science for Good. There's an organization called Data Kind, where they're tackling problems such as it's hard to know who, for instance, Data Kind did a project where they used machine learning and data science to help predict what wells were going to need to be serviced ahead of time, or whether micro-lending was working and what they could do for different types of organizations. They've also done work with machine learning and image recognition, taking a poll of a city for wealth measurement. So depending on what type of roof a specific dwelling has, you can extrapolate what kind of wealth that family or that living unit has. On the other side, you can also do things where either in predatory lending, in payday loans, or in specific sexual predatory relationships online, where you can analyze text and you can set up alerts either within websites or different things where you are looking at the data, and based on the past actions of people within that forum or people within that specific website, you can then flag or unflag them. And so there's a lot of great data non-for-profits who are tackling these types of problems.
Interesting. Can you talk about pipelines or opportunities for data science project work with data science plugins? People that are maybe not necessarily looking to work for an organization, but people that are doing their own sort of project work.
Right, so I take that to mean either you're doing some type of consulting after hours, or you're doing some type of open source work or volunteer work where you are coming in to help. Most organizations and most, that's accurate.
Yeah,
most organizations are becoming more and more aware of the fact that they have data that they may or may not be capturing. They may or may not be utilizing it in a proper way, and they may or may not know what is available. So for instance, in your local community, you can say, you know what, I really like this business. I wonder if they're capturing this data, or if they've even thought of, given this data that they have, is it something that you can help them? So for instance, I belong to my local library, and it astounds me that given the vast amount of books that I have checked out and read from them, they don't send me an email when a new book that I would like comes into the library. So that's something where I could just reach out to my local library and say, hey, I know that you are collecting this data. Why don't I help you build some type of recommendation thing so you get patrons like me coming in more often, which means I'm more likely to donate money, which means you are more likely to help out the community. It's a little bit easier with non-for-profits because for the most part, at least in the US, volunteering for a for-profit company is kind of dubious on certain legal grounds, and so they might have to hire you. Whereas if you are going in and pitching yourself as a consultant, then that's much easier, where you can come in and say, hey, look, you are probably collecting all this data, you should do this thing which will make you more money or will allow you to have more impact in your community.
Interesting. So any other sorts of ideas for opportunities for self-employment in data science? Those seem like some interesting ideas. Are there any other sort of resources you might have, or is there sort of like a particular subset of the data science community that supports each other on sort of contract work or self-employment work?
Yes, so if you are interested in data visualization specifically, there are a couple email lists that if you email me, I can tell you what they are.
Okay.
It depends on what tools you know. Specifically for contract work, there are basically any company that has a website, you could probably pitch them on some type of data science project.
Mm-hmm.
Then it becomes much more of a cold calling exercise, unless you've gone through this process and you have some type of portfolio where you can point and say, well, I've used Twitter to predict financial transactions based on the weather. Well, okay, you can go out and talk to people who are going to be affected by the weather and say, look, I can do this work for you. I've done it before. So it becomes much more of a, what is it that is interesting to you as a data person, rather than just see what comes in.
Interesting. So here's an interesting question, because I guess maybe we don't think about this a lot in sort of the technology space. Maybe we should. What are your thoughts on a place for data science in the law?
I think it's a slowly booming field that will become much, much bigger in the future. So there's companies who are working on doing discovery, and for that basically means reading through prior law or going through documents and looking for something. Mm-hmm. The way it normally happens now is you have either paralegals or junior lawyers looking through shelves and shelves of documents. So there's companies who are working on digitizing all these documents and then looking through it much quicker. Data science will hit every single company that there is. And so I think law is a great place if you are interested, because you can imagine there's a certain number of lawsuits, there's a certain number of partners, there's junior partners, there's lawyers, and depending on what they're doing, you have some type of data that's always being generated, and if you can use that data to better serve your clients or better serve the company, either on the for-profit or non-for-profit side, I think that's a wide open space and a really good place to go after.
Interesting. So tell me, either from yourself or from other people that are data scientists and people that you've helped to sort of transition into the field, what do you feel are the most satisfying, this is my career counselor in me, what are the most satisfying parts about the work that you do as a data scientist? What do you like most about it? What would be maybe things that other people from MIT might relate to that are intriguing about the work that you do as they're thinking about a transition?
So for me personally, and for the people that come to mind when you ask the question, is this idea of better understanding the world. And I think this will really hopefully appeal to the MIT alumni is, at least when I went through MIT, most of the people that I talked to were very interested in understanding the world, understanding the field that they are in. And that is something that is unique because it's a combination of understanding the business aspect, understanding the data, being able to program and actually ask the computer questions and ask the data questions. So it's this sense of continual discovery of, oh, that's how that works. Oh, that's how the world works. And I think that's an amazing ability. And then to the communication part, then being able to turn around and help someone else better understand their world, I think is at least very satisfying for me and very helpful. And sure, some people, the better they understand the world, they will make more money. And so for some people, it's a for-profit motive. For other people, it's I can help other people, or I can help other people fulfill their lives. Yes, there are obviously ethical considerations and moral considerations to take into account whenever you do any project. For instance, there was a startup that could, looking at pictures of a nightclub, tell you whether it was a heterosexual nightclub or a nightclub geared towards homosexuals. Now, there were parts in this world where they were able to intuit that information where being homosexual is against the law. So obviously, there are very strong ethical considerations and moral considerations to take into account when you better understand the world based on data. But on top of that, if you meet your ethical and moral criteria, there is an amazing feeling of better understanding the world that I think is hard to get from any other occupation.
And I guess to sort of tease that out a little further and to tap into the vast knowledge that you have, and maybe this can sort of be our last question, where do you see the field heading in the next 5 years? What do you see the biggest trends being? What do you see the most sort of new aspects of data science? Where do you think it's headed?
Sure. So the data science that makes headlines is generally we have this amazing model that is going to put people out of work, or we have this AI that's going to put people out of work. And what that misses is that for the most part, 90 to 98% of the companies out there aren't actually getting any value from their data or getting very little value from their data. So rather than fine-tuning their model to go from 98.5% predictive rate to 99% predictive rate, most of these companies and most of these organizations are going from 0 to 50. And I think that's going to be a huge boom, not only for humanity, but also for the types of things that we can do and use in our lives. And now is as good a time as any to really be able to reach out and figure out what it is that you want and be able to help and be able to work in that space. Tooling-wise, like I said earlier, the tools are going to continue to develop. Because it's a new and growing field, it'll slowly get fragmented. So at the very beginning, you saw just data scientists, and now you have data engineers who focus on getting the data from A to where a data scientist can use it. For some organizations, that will be the case where it'll slowly split up. For other ones, it won't. Another trend that you're starting to see is rather than having a data science team, it'll be someone who is embedded in specific functions. So rather than having a data science team, you will be a data scientist in legal, or you will be a data scientist in marketing, or you'll be a data scientist in HR, or you'll be a data scientist in procurement. And so I think that's something where it becomes even more interesting because you can dig even deeper into what it is that you are interested in and use data and get insights and communicate those within specific functions, within specific companies, within specific industries. So I think the sky's the limit, and it's a very exciting time to be moving into the field.
Wow, that's great. Thank you, Sebastian. I think
thank you.
We've had a lot of A lot of people thanking you very much for, a lot of people typing in the chat that they really appreciated the topic today and appreciated your time and your expertise. I think a lot of people, as Sebastian said, please fill out the survey that you'll receive today if you're looking for maybe a deeper dive in some particular areas in data science. We'd be happy for you to give us that feedback, and maybe we could do some sort of a part 2. But we obviously can't know that unless you give us that feedback. So thanks for joining us today for today's Career Lunch and Learn. Thank you, Sebastian, and have a good afternoon, everyone. Bye-bye.